balloon into the spectroscopy. Spectroscopy is basically the study of spectra and the spectral line of light, and specifically for us, light from stars. It makes it possible to analyze the light emitted from stars. When you analyze this light, you can figure out their distance from Earth and identify what they are made of and determine their chemical composition. Before we get into that though, it's probably a good thing to back up a bit. You know how when you take a crystal prism and pass it in sunlight through it, you get a spectrum which looks like a continuous band of rainbow color. The light that we see with our human eye does have a rainbow color falls in the range of what's called visual light. And visual light spectroscopy is probably the most important kind of spectroscopy. Anyone want to take a stab at the scientific curve? Because all this reading for today. Optical radiation. But I thought being exposed to radiation is dangerous. So yes and no. If we are talking about radiation, like in the elementary level, yes, that's dangerous. But radiation, as a general term, actually refers to anything that spreads away from its source. So optical radiation is just a visual light energy spreading out. Okay, so we've got a spectrum of a beam of sunlight and it looks like the color bleed into each other. There are no interest, it's just a band flowing from violet to gray to yellow to. You get the idea. Well, what happens if the silence spectrum is magnified? Maybe you all didn't do the reading well, here's what you see. I want you to know that this field is interrupted by that line called spectral lines. If you really magnify the spectra of the sunlight, you could identify more than 100,000 of them. They may look kind of randomly placed, but they actually form many distinct patterns. And if you are looking at the spectra of some other stars, the color always would be the same, but the spectral line would break it up at different places, making a different pattern. Each pattern stands for a distinct chemical element, and so different sets of patterns of spectral lines mean that the star has a different chemical composition. So how do we know which spectral pattern match up with which element? Well, was compound using flame gas. A known element, say a piece of uranium, for example, is heated in a pure gas flame. It eventually heats to the point that it radiates light. This light is passed through a prism. It breaks up into the spectrum and a unique pattern, kind of like a chemical fingerprint of a spectral line that appears. This process will be run over and over again for many different elements. So we get her. So it adds to the pattern of elements in the library. Oh, answering the story about how Arnold discovered through spectroscopy. There was a pretty extensive library of spectral line patterns of elements, even by the 1860s. Bridges was analyzing spectrographs of sunlight, and he noticed a particular pattern of spectral lines that didn't match anything in the library. So he put to and the sun hadn't been discovered here on Jersey. And I guess it's about what the element is. It actually turned out to be pretty common, and I'm sure all of you know it. Okay, let's try something else. Any of you happen to be familiar with the Greek word for sun by chance? Something like Helios or something else. Oh, it must be helium. So you're saying that helium was discovered on the sun first? Yes, and this is a good example of how important the spectroscopy is in astronomy. Growing.